Good morning. I'm G. Prabhakar, Assistant Professor, Department of Basic Sciences and Humanity, and B.V. Raju Institute of Technology, Narsapur. The course is Engineering Chemistry. Topic for today is corrosion. So, what corrosion is? Here, generally, in our everyday life, we are going to observe few metals. On these metal surfaces, we are going to see like a yellow color layer or brown color layer on the surface we are going to observe. The best example in our everyday life is iron. This iron, when we have thrown a piece of iron somewhere and we observe this iron after 3 or 4 months, we are going to observe a brown color layer formed on the surface. Do you know why it forms? That is the phenomena corrosion. So, what is this corrosion exactly? That we'll see. Corrosion is any process of destruction and consequent loss of a solid metallic material through an unwanted chemical or electrochemical attack by its environment, and starting its surface is called corrosion. Means corrosion is a surface phenomenon, because whenever we have thrown a piece of metal, suppose if I take this is a piece of metal, that is iron. Now for this iron, assume it is as the surface of iron. Assume this part as surface of iron. Now this surface, now this surface, it was directly access of, means environmental oxygen can able to attack on it. So environmental oxygen. So there is a direct access only on the surface, due to which corrosion takes place. In general, we are calling as, for suppose if it is iron, in general we are calling it as rusting. Rusting is taking place for the iron. So rusting of iron is the best example for the phenomena called corrosion. So corrosion is a surface phenomenon. So once again, what is corrosion? Any process of destruction and consequent loss of solid metallic material through an unwanted chemical or electrochemical attack by its environment, starting at its surface, is called corrosion. So all the environmental oxygen attacks on the surface of the iron. So obviously this iron undergo corrosion. Next, even we will get a doubt. Why? Generally, why these metals undergo corrosion? Okay, so a question arises, that is why. Why metals undergo corrosion? We all very know that, see, on the earth crust, under the earth crust, metals are not available directly. Like we have an iron rod, aluminum rod. Likewise, we don't get pure form of metal. All the metals are available in the form of their metallic ores. Say bauxite, ore of aluminum; hematite, ore of iron. Likewise, all the metals, even pyrolusite, ore of manganese. So likewise, all the metals are available in its metallic ore form. Generally, all the metallic ores are in its oxide form. Suppose if you take pyrolusite, in pyrolusite, manganese is present in the form of manganese dioxide. So likewise, under the earth crust, almost all metals are available as its metallic ore. So these metallic ores are ground state materials. We already gone through the concepts like this ground, any particular material which was in ground state, Ground state material is associated with high stability. So stability is high and energy is low. Now, when during purification of metal or extraction of metal from metallic ore, we are going to provide some energy to this ground state material. Now, it enters into excited state. So, due to supply of some energy, ground state metal enters into excited state. Now, for this excited state metal, stability is less and energy is more. Due to its less stability, this excited state material always tries to come to the ground state by releasing some energy. This is the reason behind corrosion. So, always this excited, generally metals are there at excited state. This excited state metal always have a tendency to come to ground state. That is the reason corrosion happens. Okay, what happened when corrosion takes place? So, as it is going to take place on the surface, metallic structure get decayed every day. Likewise, strength of the metal get decreases. So, likewise, corrosion happens. And here, there are several types of corrosion. So, what are the types? We'll see now. So, coming to types of corrosion. This classification is made only on mechanism. What type of mechanism this corrosion follows? So, based on that, the entire mechanism of corrosion only of two types. One is dry corrosion, which is also called as chemical corrosion, and other one is wet corrosion, which is also called as electrochemical corrosion. So, based on the mechanism, corrosion is of two types. One is dry corrosion, another is wet corrosion. Here, we are calling this dry corrosion also as chemical corrosion. Why dry corrosion is called chemical corrosion? Because the mechanism involved, only a chemical reaction, that is simple oxidation, is taking place for dry corrosion. And here, wet corrosion, where it is forming a electrochemical cell. Okay, so within the metal surface, which is forming a electrochemical cell. So what is an electrochemical cell? Which constitute an anode and a cathode, and flow of electrons are there from anode to cathode. Generally, this setup we are calling as a electrochemical cell. Here, during this wet corrosion, it is going to form a electrochemical cell on the surface. Okay, so in that way, in that mechanism point of view, the corrosion is of two types, dry corrosion and as well as wet corrosion. So let us see detail about one by one. Let us see about dry corrosion and as well as wet or electrochemical corrosion. Fine. So dry corrosion. This dry corrosion is also called as oxidation corrosion. Dry corrosion is also called as oxidation corrosion. Why we are calling dry corrosion as oxidation corrosion? Because here the mechanism involved is simple oxidation. Oxidation is going to take place on the surface of the metal. That is the reason this dry corrosion is called oxidation corrosion. So here a chemical reaction with the metal happens. Means during dry corrosion, a metal which reacts with the environment, oxygen, and it will releases some n number of electrons. And see here, this is the metallic surface. On the surface, oxidation is going to take place. That is the reason dry corrosion is called oxidation corrosion, because the chemical reaction involved during dry corrosion is oxidation. So we are calling this dry corrosion as oxidation corrosion. Okay, so how it happens? It happens only due to the exposure of environment. So environment may contain several gases, but here especially we have what is the chemical reaction that is taking place? That is oxidation. So we have considered that particular oxidation. So likewise, dry corrosion is called oxidation corrosion. So here a metal undergo oxidation and it combines with oxygen, like a metal and combination with an oxygen, it is going to form metal oxide layer. During dry corrosion, metal combines with oxygen and it is going to form metal oxide layer. See here, this is the metal oxide layer proportion we have. So on the entire metal surface, the metal oxide layer is going to form as a coat. So further also, whether corrosion takes place or not, it depends on the nature of metal oxide layer which is formed. So whatever metal oxide layer which is forming, based on the nature of this metal oxide layer, further corrosion takes place or not. That we can see. That we can decide. The only thing is, like, if metal oxide layer is one type, corrosion takes place or not, or another type, intensified corrosion. Likewise, further corrosion. See, first it is a metal. This metal reacts with environmental oxygen, undergo oxidation. Suppose if it is a metal. So on the entire surface, oxidation takes place. Okay, likewise. So this is the coat, means metal oxide layer. Got it? This is the metal, and whatever that is surrounding is this all metal oxide layer. See, so this metal oxide layer is totally covering the metal surface. So further step of corrosion. So this corrosion taken place already at one. Now this whatever metal oxide layer that is formed, that is surrounding this metal, furtherly whether corrosion continues or not, that depends on this nature of this particular metal oxide layer. Based on the nature of metal oxide layer, we can decide whether further corrosion takes place or not. Okay, so let us see now. So oxidation corrosion, generally this type of corrosion is carried out by direct action of oxygen, and of course this type of corrosion takes place in the absence of moisture. So like the air should be free from moisture. Okay, so in the mechanism, as we already earlier discussed, initially surface undergo oxidation and the resulting metal oxide scale forms a barrier, like what I have explained previously. So this metal oxide layer, it acts as a barrier which restricts further oxidation. Okay, and furtherly it depends on nature of the metal oxide layer. Okay, if metal oxide layer, whatever metal oxide layer, see, we are calling it as, it is a metal. This metal, after oxidation, it is forming a metal oxide layer. See, this is the surface, assume this is the metal oxide layer. So if this metal oxide layer is stable, then corrosion takes place only once. Means metal undergo oxidation and on the surface a metal oxide layer forms. Thereafter, this metal oxide layer itself acts as a protecting layer for the metal. So this metal oxide layer which surrounds the metal, so it doesn't allow environmental oxygen to enter in, so that it is going to act as an inert barrier between the environment and as well as metal. So further, no corrosion takes place. Example, if you take copper undergo corrosion only once. Thereafter, whatever copper oxide layer which is formed, that layer itself surrounds the metal and it acts as a protective layer. Same is the case with aluminium, lead, etc. Okay, so likewise, based on the nature of metal oxide layer during oxidation corrosion, based on the nature of metal oxide layer, we can judge whether the corrosion takes place further or not. So that is case A, where metal oxide layer is stable, so corrosion takes place only once, thereafter no corrosion. Next, if the metal oxide layer which is unstable means, see here, metal, this is the metal, this is the oxide, and it is going to form a metal oxide layer. And again, this metal oxide layer get back as metal and as well as oxygen. So it is quite unstable. Means here there is no probable scope of undergoing corrosion. So here in this condition we will call it as no corrosion. Corrosion doesn't happen here because why? Metal and oxide, it is forming metal oxide layer. Again that metal oxide layer is dissociating as metal and as well as oxygen. So in such conditions no further corrosion takes place. Okay. So that is the reason we will call some metals as inert to environment like gold or silver. Why? Because the metal oxide layer which is forms, and again it is reversible. It forms and again it will dissociate like reactant and as well as a metal. Okay. The third condition, metal and oxygen. It forms a metal oxide layer. And this metal oxide layer is volatile in nature. This metal oxide layer is volatile. What is volatility? Volatile means readily evaporatable. If it is in a readily evaporatable condition, what is going to happen? See, every time metal reacts with oxygen, it is going to form metal oxide layer. So over a period of time, this entire metal oxide layer evaporates, and again there is a fresh metal surface. Again oxygen attacks, again it will form a metal oxide layer. Over a period of time, again it undergo evaporation, again there is a fresh metal. So likewise, intensified corrosion takes place. If the metal oxide layer is volatile, intensified corrosion takes place. Okay, so likewise, corrosion here it will become a rapid corrosion or intensified, or we can better call it as rapid. A rapid corrosion takes place. Okay, and finally, last one is, so example for this is molybdenum oxide. When we have taken molybdenum as a metal, if you place a molybdenum metal outside, this molybdenum easily attacked by environmental oxygen and it will form molybdenum oxide layer. It is volatile in nature, it evaporates, and furtherly a fresh surface. Likewise, it undergoes intensified corrosion. And finally, if it is porous, the metal oxide layer is porous. So if it is porous means like a metal reacts with oxygen and it is going to form a metal oxide layer. Now porous means it is discontinuous. Means this metal oxide layer here, it is having some pores, some cracks on that. Now from this cracked area, there is a provision for atmospheric oxygen to enter. So here corrosion, continuous corrosion takes place. Okay, so likewise corrosion continues. Example, lithium, sodium, potassium, whatever. Okay, so likewise the first oxidation corrosion. So during the oxidation corrosion, first metal reacts with oxygen and it is going to form a metal oxide layer. Further, it depends on the nature of the metal oxide layer. If it is stable, then corrosion takes place only one time, Thereafter, no further corrosion takes place. If it is unstable, no corrosion, corrosion doesn't take place. Or then metal oxide layer is volatile, then rapid corrosion takes place. Then if it is porous in nature, in that particular condition, corrosion go on continue. Corrosion continuous, we can say. Okay, so likewise, the nature of the metal oxide layer which forms, which decides the extent of corrosion during dry corrosion. So this dry corrosion, we have also called this dry corrosion as chemical corrosion. Okay, why we are calling it as chemical corrosion? Because here the corrosion is taking place due to the chemical action. Due to the chemical action, only corrosion takes place. That is the reason this corrosion is called as dry or chemical corrosion. Then what is the mechanism involved during this dry or chemical corrosion? The mechanism involved is oxidation. So we are calling it as oxidation corrosion. This dry corrosion is also called as oxidation corrosion. Okay, so this is about corrosion, causes of corrosion, types of corrosion, and in that type today we discussed about mechanism of dry corrosion and conditions in which conditions the dry corrosion is more, like the nature of metal oxide layer, is it stable, unstable, volatile, porous, etc. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.